Okay, sir. So today, let me talk about the damage curve. This one. Okay. You're able to see? You're able to see
Yes, sir.
Yes.
and able to hear clearly?
Yes.
Yes, sir.
Yeah. So you see this damage curve. Uh, See the damage curve. You can see what is the damage curve in the first this one. Damage curve is basically any equipment can be operated up to certain limit, just like human beings. If you operate beyond that limit, the equipment get damaged. Simple. So the damage curve, who gives the damage curve? Who develops the damage curve? Damage curves are not developed by any simulation or calculation. They have done a lot of testing and they have given these curves. So any big job, if you're doing, you have to get the damage curve from the vendor itself. Okay. Small transformers, you can refer standards and assume the damage curve. Suppose you are doing relay coordination for, let's say, 20 MVA or 100 MVA or a 200 MVA transformer. Then you have to ask the damage curve from the vendor. He would not have tested for those big transformers. He would not have, tested the damage. But based on his design, one or two, he would have done the test long time back. He would interpolate and give you. So please ask the damage curve from the vendor. Okay. Now, see, I want to ask you one question. All these are related. Damage curve, insulation class, all these are related, right? So what is the insulation class we use in motor? Mr. Naveen Kumar. Mr. Naveen Kumar.
I don't have any idea, sir.
Just, okay, sir, no problem. Our Mr. Vijay, Mr. Vijay. What is the insulation class, sir, we are using in the motors? Mr. Vijay.
I think it's class B and class F installations.
Class B and class F, huh?
Uh,
Okay. I think you are correct. Class F limited to class B, something like that in the data sheets even I have seen. You are correct. And you can mute, sir. You can mute now. Yeah. And Krishna Kumar.
yes, sir.
For the transformers, you have come across insulation class during the preparation of
Yes, sir. Class A.
Session?
Mostly oil filled class A only, sir.
Class A.
And a dry type up to class H or class F.
Pardon, sir?
For dry type transformer, class F or class H.
Okay.
Oil filled mostly class A.
Class A. Okay. Thank you, sir. Thank you for sharing your knowledge. So there are different classes A, E, B, F, H. For motors, they are using F limited to B. And for, as Mr. Krishna Kumar said, for dry type transformer, it is yeah. For oil transformer, it is A. And actually, in a oil transformer, let me talk about the oil transformer now. When I say 105 degrees Celsius temperature rise, what it means is the rise delta T is 105. So if the ambient temperature is 50 degree, then the temperature limit has to be 150. Okay. For the 150, there are some, I think there is some 5 degree difference between oil and binding. Now, if this temperature increases, what will happen? Why? First thing is why the temperature comes. See, current is flowing inside the coil. There is your I square R loss. Coil will immediately transfer the heat to the winding, from winding to the core, and from core to the oil. Okay. So it is the oil which gets heated up, and finally the hot oil stores energy. Okay, it stores energy. After up to some level, it will store. Then it will give out the energy, and that energy is dissipated by the surface of the transformer. You all know how it looks like. So there is a continuous process: generation of heat, storage, and distribution. Okay. Coil will generate the heat, oil will store the heat, external surface will dissipate the heat. So based on these three process, an equilibrium will be attained, and that will give the temperature. Okay. So that temperature, if it is 150 degrees Celsius, what happens? What happened if it is 160? What happened if it is 200? Pinaki Sharma.
You'll have an insulation failure.
Okay, the insulation will fail. Okay, no, it will not fail immediately. See, if my speed limit of my vehicle is 80 kilometers per hour, if I go in 100, immediately nothing will happen, right? But the way
Ultimately, it will get hot and it will get hot. It will reach some threshold value, and then you will have. Ultimately, it will lead to an insulation failure only, or
ultimately,
something.
so what happens is basically first thing that happens at that time. Yes, ultimately you are correct. At that time, what happens immediately is there is a loss of life, right? So, suppose, like you said, insulation failure. Okay, if you want to do insulation failure, fine. At what time? Next question. Suppose I'm going to load my transformer. You see this twice the current. You're able to see this table.
Yes, sir.
Suppose I load the transformer to twice the current. Immediately nothing will happen, but it will take some time, like 1800 seconds. After that only there will be a failure.
So the time that they're saying means 2 times the rating of the transformer. It will take 1800 seconds. After that, it is transformer failure only, no?
See, after that it is transformer insulation failure only.
Failure only, no? Okay.
But one thing, these 2 times when you load the transformer, see, when you load a transformer at twice the current rating, before 1800 seconds, the transformer might not have failed, but it will lose lot of life. For example, a transformer which will come 30 years may come only, see, 1800 second is how much in terms of minutes? 60, 30 minutes, right?
30 minutes,
30
half an
minutes.
hour.
But transformer will not lose 30 minutes. If the transformer has to come for 30 years, it will lose around let's say 2, 3 years, sometimes 4 years, 5 years, like that. So when you overload a transformer at these values, if you overload a transformer at 2 times the current up to 1800 second, it will not fail. Beyond 1800, it will fail, but it will still lose lot of life. Okay, its life expectancy reduces. But when we are doing the relay coordination, you have to remember why I'm explaining this is when we are doing relay coordination, I am not concerned about the loss of life of a transformer. I'm only concerned whether today my transformer will break down, whether it will catch fire. I am only concerned about that. Okay, so based on that, we have developed the damage curve of the transformer. Okay, so it is clear what is damage curve. So this damage curve basically depends on the insulation class, temperature rise, all these things. Okay, and all these damage curve are inbuilt in our relays also. Like not all relays are having, but most of the nowadays relays are having. Actually, our present day transformer protection relays are having a lot of curves inside. But we don't actually this simulation software has for sure the if you are how many of you use ETAP or SKM, who all have used? You have used ETAP, okay. So you see in all these softwares, no, like our ETAP, SKM, Paladin, these softwares are having inbuilt damage curve. So you just have to select those damage curve. That's all, nothing else. Whereas since, see the reason why I took up this topic doing relay coordination manually using Excel is here we have to create our own damage curve. Later on I will teach you how to create your own damage curve. So in a way we are learning how the guy has done for the software. It is good. We get the basics. Otherwise, what happens when we are doing simulation? I will just take the transformer rating. I will add the damage curve. That's all. Okay. So where do I get the damage curve? Two places. One is you ask the vendor for big ratings, and you can also go through the standards, our ANSI standard. Any idea whether our IEC is having damage curve?
10 to 12 times, no?
Pardon?
10 to 12 times as per 76, IEC 76.
No, in the transformer IEC, have you come across damage curve?
Means yeah, normally it is 10 to 12 times rated current.
Okay. So this ANSI is giving a very beautiful this damage curve. So you can refer this also. So let me open for your this one. Let me show you one good source. Okay, I will share that link also. And later on you can go through that link. It is a very good source of information. As and when I do, I will share the sources which I have been using. So Mr. Gaurav, you have joined, sir.
Yes, sir.
Welcome, sir. Welcome. Okay, I am sharing our, SKM. How many of you have used this SKM? It is just like ETAP. Vijay Kumar, you have used SKM?
No, sir, I've not used it.
SKM is just like ETAP. Actually, in our Shell, they use SKM, and all those contractors who work for Shell, they use SKM. Okay. So if you go, I've shared this link via WhatsApp also. So actually, you please go through this for additional learning. They have given very good information about this damage curve and okay, they have also given you see here this is the curves where they have given in terms of per unit current and the withstand time. So they have given for different ratings 500 to 5000 kVA. Okay, you go, please go through this link. It is very helpful. I just wanted to share This transformer inrush, I will tell later on. And there is some example here. You can go through that also. Okay. And when you use the software like ETAP or SCAP, see the damage curve is added by the software itself. But it is good to learn how to make a damage curve, how to generate, where to get. That is good because then we come to know how exactly the guys working in software does it. Okay. So I'll stop sharing this. I will go back to the presentation.
Sir, one doubt in this,
Yes, sir.
damage. Sir, this while we are modeling in ETAP, no? This transformer cooling type, we are not, some contractors are not much giving importance to that, but whether it is important, sir, that with the ONAN, ONAF for this damage curve plotting.
I didn't get you, sir. The transformer,
In transformer properties in ETAP while modeling,
yeah.
I have seen some contractors normally they will go ONAN or AN, they will not much stick on to it and change the in transformer properties in ETAP while modeling.
Okay, in ETAP, actually,
I-
uh, in the ETAP, if you don't select the proper this one, then what happens is your this damage curve get affected because ONAN damage curve is different, ONAF damage curve is different. ONAF has more capability. So selecting that is very important actually, because what happens, your temperature rise limit will be higher in ONAF, and the temperature rise is higher and the overloading also is more. So in ETAP, any of the software you have to select the correct this one, ONAF or ODAF, whatever it is.
Okay, sir.
Yeah. Maybe one sometime, I will myself write down, suppose how to modify the damage curve. How can we modify the damage curve with respect to the type of, based on type of cooling? Any idea? Suppose, okay, this is the, I have given the damage curve of a transformer. You are going to create a curve and add in the, the curve. But suppose I'm going to change the type of cooling. How will you add your damage curve? How will you modify? Okay, that is one exercise for you. Please think and answer it by, you take your time, you go through some material in the net, go through publications, IEEE, CRED, all those, and you let me know. Okay, you let me know how can I modify the damage curve. Okay, how can I modify the damage curve based on the,
Why should we modify a damage curve? It is what it is, no, sir. I mean, based on what the vendor tells you.
No, see what I'm telling. If the vendor has given you the damage curve for a ONAF transformer, fine. Okay. Suppose vendor has not given you the damage curve. You have the damage curve from the standard for a ONAF transformer. Okay. But in reality, the transformer is operating as ONAF. So how can I that time modify? That's what I'm asking.
You'll have to get us another curve for that ONAF operation. You have to get a separate curve.
You are correct. We have to get the curves from the vendor. Suppose the vendor has not given us something. How can we interpolate? That is what I'm asking. Just suppose we don't have the data immediately. We want to generate a curve. So how can we do it? Or other way I will put other way. Can I plot two curves, ONAN and ONAF damage curve, and compare how they look like?
Yes, sir, you can do that.
Yeah, okay, that you can check. We will. That is one thing. Okay.
Excuse me, sir.
Yes, sir.
So, sir, in previous slide,
Yeah. Yes, sir.
here is a multiplied of the rated current and there is a time in second. So what is the physical interpretation of this? Say 2 times of the rated current, then it will damage within 1080 second. Is it like this?
Yes, sir. It is like that only. 2 times the current, 1800 seconds.
Insulation will damage, like,
Yes, sir. Yes.
okay.
But before that also, if I keep running, what will happen is life will come down. Okay, sir. And this table is for tri-type transformer. Okay.
So is there any IC standard for the damage curve?
Let me check, sir. Actually, a transformer I have not seen. But I will check and get back to you. Whatever this query you can post in the WhatsApp group also, sir. I will also check and come back to you. Okay. Okay. Now let me go to the cable damage curve. See, for cable, the damage curve is very simple. I have actually taken from this Ducamp, nice cable vendor. See, any cable you go, the short circuit rating is given. For cable, actually, see, if it is a static equipment, there is damage due to only thermal effect. If it is a rotating equipment, there is damage due to thermal and mechanical. Okay, remember these two things. If it is a static equipment, not statically covered cable, transformer, damage is only due to thermal. Okay, sudden short circuit, the peak current will cause forces inside the transformer. That is also causes problem. No, okay, I am not telling that it does not cause. But when we are plotting all this damage curve, we are only writing the thermal effect. And when we are going to plot the damage curve of a motor, you will see, there is a mechanical this one also. Actually, even in transformer also, if you see up to a low current, it is thermal effect which dominates. But at very high current, for example, 40 kA, 25 kA, it is the mechanical thing which dominates because the short circuit forces will cause like our Mr. Gaurav will tell, sir, Gauravji.
Yes, sir.
In your switchgear, there is a bus bar compartment, right? At the top.
Yes, sir.
And that bus bar you are supporting using what insulation, sir?
So we use generally FRP based or epoxy based and sometimes SMC based insulators. So besides the type of insulators, the critical thing is one of the things that contribute towards the behavior of the bus bar during a short circuit is the thickness of the bus bar, number of bus bar, level of short circuit, the gap between the supports that we have given, and the face-to-face center-to-center distances that we maintain.
Exactly, sir. Thank you. So our Gauravji, if you listen to what he said, two things we can summarize. The bus bar undergoes heat, the thermal effect due to a short circuit, and also when there is a fault, there is an enormous amount of short circuit force between the bus bars. And this insulator, which is holding the bus bar in a bus bar chamber in your switchgear, that has to withstand the temperature and it has to withstand the short circuit force. Okay. So initially, when the same concept, now I will tell you in transformer also. Transformer also, you have winding, they are holding each other. Insulation is, the work of insulation is number one, it has to tolerate the temperature. See, insulation's work is actually to give insulation, but it has to tolerate two things. See, when you are doing your work in your office or where you have to tolerate certain things along with your work. Similarly, for insulator, there are two things to tolerate. One is it has to tolerate temperature, it has to tolerate force. From 100% current up to, let's say, 1.1 times up to 10, 15 times something, it has to tolerate the temperature. But after that, let's say 25 times the current or 100 times, like huge currents, the force matters. And in the relay coordination curve, you will see later on that the coordination initially is dominated by the thermal effect only. Okay. Any doubts here, sir?
Sir, I just have one thing in this table 13,
Yeah.
that conductor size is for that mm square, no sir, and that short circuit is for the aluminum. Those values coming under aluminum conductor and this one, correct, sir?
Okay. This is copper conductor, sir. The table.
No, sir, it is no. Is it copper? But it is for both, no, sir. That is for aluminum and copper conductor, no?
Yes. For 50 square mm, the short circuit rating for copper is 7.15 kA, and for aluminum it is 4.7 kA.
Okay, sir. Sir, then in the second table, sir, we saw yesterday that we have the current in the x-axis and the time in the y-axis, but here it is opposite, no? What we have for
This
these two tables.
This one is developed by a vendor just for in his catalog or a manual. Okay. So
Okay.
for us to give data, he has made it. That's all. But when we are making our I square T curves, we will keep current only in the this one x-axis.
X-axis, huh?
Yeah.
Okay, sir.
Okay. So what basically I was trying to tell is more our transformer, our cable, our motor, our generator all have damage curve, but in all damage curve, thermal and mechanical both will dominate. Okay, and the thermal part will dominate initially, and the mechanical part will dominate later on. That I will show you. See, when I'm plotting the curves, I will show you how the damage curve. For example, I will explain you later on. The first left side it is thermal, and right side bottom it is the damage is by mechanical. And in case of rotating machine, stator, rotor, both curves also will come. Okay. Now here I will explain this. See here this a 50 square mm. Yes, sir.
Sir, our session will expire within 2 minutes. I think we have to start it again.
Okay, sir. I will stop and start again. Thank you, sir. Done.